Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the thermocouple is based on the effect discovered by Civic in 1821 of the circulation of current in a closed circuit formed by two different metals whose junctions are kept at different temperatures. These unions are hot and cold. This current circulation is due to two combined thermoelectric effects, which are the Peltier effect and the Thomson effect. The Peltier effect causes the evolve or absorption of heat at the junction of dissimilar metals when a current flows through it. And the Thomson effect consists of the evolve or absorption of heat when a current circulates through a homogeneous metal in which there is a temperature gradient. In this image, this effect is exemplified in a thermal cross formed by the union in its center of two different metals. A current is passed in one direction or the other with the K2 switch open. After each passage of current, K1 opens, which disconnects the battery, and K2 closes, reading in the galvanometer the EMF or electromotive force created, which is proportional to the temperature reached by the thermal cross. It will be observed that by subtracting the ohmic heating, which is proportional to the square of the current, there is a remainder of temperature that in one direction of the current circulation is positive and negative in the opposite direction. The effect depends on the materials that make up the joint. The Thomson effect can be detected in this circuit, which is formed by a metallic bar Mn with an isolated differential thermocouple AB and a coil H for electrical heating centered with the AB relation. In regime heating with the coil H, one of the points, for example B, will present a difference of temperatures with the A, which will be accused in the galvanometer. If current is now passed through the Mn bar, an increase or decrease in the differential temperature will be noticed, with the opposite effect if the current is reversed. The combination of these two effects is the cause of the flow of current when closing the circuit in the thermocouple. This current can hit the thermocouple and affect the accuracy of the temperature measurement, so its value should be minimized during the measurement. The study of the behavior of thermocouples has made it possible to establish three fundamental laws. Law 1 is the law of the homogeneous circuit. In a homogeneous metallic conductor, the circulation of an electric current cannot be sustained by the exclusive application of heat. The second one is the law of intermediate metals. If in a circuit with several conductors the temperature is uniform from one solder point A to another point B, the algebraic sum of all the electromotive forces is totally independent of the intermediate metallic conductors and is exactly the same as if A and B were put in direct contact. The third law, or the law of successive temperatures. The EMF generated by a thermocouple with its junctions at temperatures T1 and T3 is the algebraic sum of the EMF of the thermocouple with its junctions at T1 and T2 and of the EMF of the same thermocouple with its junctions at temperatures T1 and T3. By these laws, it becomes evident that a small direct voltage is developed in the circuit proportional to the temperature of the measurement junction, as long as there is a temperature difference with the reference junction. The values of EMF are tabulated in conversion tables with the reference junction at 0 Celsius. Here we can see the characteristic curves of the thermocouples, which can be used as a guide in their selection. The selection of wires for thermocouples is done in such a way that have adequate resistance to corrosion, oxidation, reduction, and crystallization, develop a relatively high EMF, are stable, low cost, and have low electrical resistance, and that the relationship between temperature and EMF is such that the increase in this is approximately parallel to the increase in temperature. It is recommended that the thermocouple have a thrust spring to configure the contact of the element with the bottom of the protection sheet, and thus obtain a response as quickly as possible. Skin points are used to measure the temperature of a surface, and are embedded in a sheet that can be bent and that is welded to the pipe. From a control point of view, and where more accuracy is required, Intelligent temperature transmitters are used, with direct analog 4 to 20 mA DC output or digital with HART protocol. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!